This is again leg A of the Strandbeest. What we want to do in this short YouTube video is explain the relationship between these values here and the lengths of the lines here, and then also some of the relationships, whether they're perpendicular or parallel lines. So let's look at that. We have alpha equals 230. This angle here, which is the rotating part of the motor, is 230. So whatever alpha is how much this angle here is, starting at BBB. Then BL is 2.5. BL is body length. Body length is the length of the line segment AB. So BL is body length. If we change this slider, the length of AB should change in our construction. M is the length of the axes on the motor. So here's the motor. The motor is tied at BB and it rotates point C. And the distance between BB and C is this motor length. If we make M bigger, this length should get bigger. If we make M smaller, it should get smaller. So this is the motor length right here between BB and C. PC. P means pelvis, C means point C. So PC is the distance from point C to the pelvis point. So this distance here is PC. It's the distance between the pelvis and point C. This is for leg A, but it's going to be the same distance for leg B, C, D, for all four legs. So PC means the distance between the pelvis point and point C. PHA, notice it has three letters. That's pelvis, hip, A. So two lines are the same length. They lie on the same circle with center A. The distance from A to the pelvis point is PHA, and the distance from A to the hip point is PHA. They are on the same circle. We find this point as the intersection of two circles, and then this one, first we draw a normal, a line normal. This angle will always be 90 degrees to find the hip point. What's the next one down? BC. BC is the distance from the point C to B, which is the back of the leg. So from point C to the back of all four legs, this is leg A, is the distance BC. So if we change this BC, this distance connecting the motor to the back of the leg will change. The distance from the back of the leg to point A is here. From point A to the back of the leg of any of the legs is BA. And then the important thing to be able to find this point here, the knee point, is to say these two lines are parallel. So the line coming through AH has to be parallel to this line, and the line joining A to the hip has to be parallel to the line joining the back of the leg to the knee. So that's how we find this point here, the knee point. We construct two sets of parallel lines and then find the intersection point. This is a parallelogram, not a rectangle, right? And then get from the back of the leg to the foot. We have the back of the leg foot distance here, and we also make a right angle, a 90-degree angle between this joint from the back of the leg to the knee and between the back of the leg to the foot. So this is a 90-degree angle. And then we just join that point to this point. Finally, the foot is just like the body. The body is horizontal and the foot is horizontal. No matter what the leg is doing, the foot will be horizontal and the body will be horizontal. So to the foot point, we add the length of the foot to the horizontal and get the toe point. So those are the controlling factors. We have the sliders and these four angles. a right angle, two sets of parallel lines, and another right angle.